1. Hello and welcome one to Calculus 1. Nice.
Wait, it's the last one. Should we do something?
So,
Yeah, we should. Wait, why?
we are going to talk about U substitution. And this is, as I mentioned, if you are going to Calculus 2, one of the most important sections of the semester. So Calc 2 is half integration and half sequences and series. And almost every integral later on is going to be converted into the form where U sub can be used. Oops, I missed. There is an S in the title, which I missed, so now I have to fix that. Yeah, there's an S there missing. There you go. Fixed. All right, so let's see. What was the most used technique to take derivatives?
Chain rule.
Chain rule. So U substitution is backwards chain rule. It undoes the chain rule. So every time when you solve integral problem using U substitution, if you are going to check that, you will actually have to use chain rule to take the derivative. So we learned so far only basic integration. You learned that, let's say, integral of 2x plus 1 dx is equal to x squared plus x plus c. That's what you learned. And you also learned that if you have limits, let's say 3 to 5 of something, I don't know, x cubed, whatever. No, it's going to be crazy to compute. Just x minus 1. There you go. Easy to compute. It's going to be x squared over 2 minus x computed from 3 to 5, which gives you 25 halves minus 5 minus 9 halves plus 3. So 25 minus 9 is 16, divided by 2 is 8, minus so 6. So those are the calculations that we know so far. They're basic integration. What we are going to discover today is how to do the integral that we have 2 to the x plus 1 raised to 19th power dx. Now, what you could do is you could sit and actually FOIL this, right, 19 times, and then do the derivative, which would take some time. Or you can use U sub. Now, this is the way of thinking that you need to adopt when you're solving these problems. You are going to say here, if this was one thing, see, I'm making it disappear. If this was one thing, then that one thing to the 19th is easy to integrate because it's just whatever to the 20 over 20, right? We use the rule. So that's where we get the method. We are replacing this 2x plus 1 with u. And now we are changing the domain from domain x into domain u. So all of this becomes u to 19. The problem is this dx. We have to have du. So to get du, you will always differentiate your u sub, and you will get du over dx is equal to 2 in this case, from where you ship dx to the other side, and you get that 2 dx is equal to du. Now, you don't have 2 dx. You have 1 dx. So what you can do is you can fix it. You can put 2 and 1/2 to counter that 2 that you put out of nowhere. And now you have your du, because that 2 and dx together make du. So the integral becomes 1/2 integral u du, which is 1/2 u squared over 2 plus c. Oh, to the 20th. You're right. 20th, 20th. This is 19 over here. Yep. So it's 1 over 40 u to the 20 plus c. Now you cannot leave u because the problem was posed in x's. Your answer needs to be given in x's as well. So what you can do is you can say, I don't care about u, I care about the x, right? So you have 1 over 40, 2x plus 1 to the 20 plus c. And now this is the answer. As you can see, it's in x values.
Could you also substitute the dx for dx half du?
Yes, that's going to be a different way.
Half du into du.
Yeah, I'll explain that as well. So now I want to differentiate this and make sure that this is correct because I care. So I'm going to take the derivative in respect to x of 1 over 40, 2x plus 1 to the 20 plus c. And that's going to be, copy the constant, 1 over 40, then 20 goes down, 2x plus 1 to the 19, times derivative of the inside, which is the chain rule, and then derivative of plus c is 0. Now you see that 2 times 20 is 40, so all of them cancel, and you're left with what was in the integral. So the answer is definitely correct. And that's how you would check these. Let's say you're supposed to integrate 3x squared minus 5 under the square root dx. Again, you say, I know how to integrate root x. I don't know how to integrate. Oh, sorry, I put a square there. I need x outside. So you go and you say, I know how to integrate square root of x. I don't know how to integrate the square root of complicated expression. So you say, I'm going to take whatever is under the square root and make that one variable, from where we get that the du is 6x dx, right? Because the derivative of 3x squared is 6x, and then minus 5 is 0, right? So now you're looking at the problem. You don't have the 6, so you fix that. You plug in 6, you put 1 over 6 in front to counter it, and now 1 over 6 integral. All right, so now this stuff is du. So 6x dx is du, and I have square root of u du. So you see how much easier, how simpler the whole thing is. Now we know how to integrate this. It's integral of u to 1/2 du, which gives us 1 over 6 u to the 3/2 over 3/2 plus c. That is equal to 1 over 6 times 2/3 of u to the 3/2 plus c. And now we just substitute back x. So 2 and 6 will cancel. We get 1 over 9. I'm not going to do the square root. I'm going to actually put 3x squared minus 5 to the 3/2 plus c, and that's the answer.
Where did the 1, 6, and 6 come from?
When I differentiated u substitution, I have 6x, right? Original problem did not have 6x. So I put 6 because I needed the 6. I put 6 out of nowhere, and then I'm countering that 6 that I put out of nowhere with 1 over 6 because they cancel down to 1. You can always fix constants. You cannot fix variables, but you can fix constants.
So then what happened to the first x? First, the original problem, there's x times, and then at line 2, the x disappears.
Well, all of that is, so all of this is du. So all of that together, 6 times x times dx is du.
So by adding the 1/6 and by changing the dx to du, you get rid of the first x.
Yes. If that x wasn't there, this would be a calculus 2 problem using the trig substitution rather than this, which is a tag more complicated, takes about a page and a half. All right. Let's see. So integral of sine 4x dx. Do you remember that one?
Yeah.
What are you supposed to do?
Wait, it's just integral sine divided by 4x, right?
Okay, so what's the integral sign?
Integral sine is
Negative cosine.
of course.
So you should know that this is negative 1/4 cosine 4x plus c, because you memorized the formula earlier with sine ax, and you know it's negative cosine ax over a plus c. But I asked you to memorize that for time being because we needed that result to do problems. However, now you have the tool to actually prove that, to do that integral, so you don't have to memorize it, you don't have to remember it anymore. If you want to solve the integral of sine 4x dx, you say u equals 4x, because then you will just have sine of u, which is easy to deal with. So you are replacing the entire 4x with u, and then you have du is 4 dx. Observe that you don't have a 4. So you are going to put the 4 that you're missing and put the quarter in front to counter that 4. And now it becomes 1/4 integral of sine u du. So the 4 that you put in and the dx together are creating du. 4 dx is du. So now, simply integrate negative 1/4 cosine u plus c, and then we say, I don't care about u, care about the x, right? Which means you put 4x plus c, and there's the answer. So from basic, your job is with u substitution to create a basic integral so that you can work the problem out, actually. So let's see. Integral of five root x minus 3 over root x dx. Let's see if you could figure this out. All right, so what is the substitution? What's the substitution? How much? You can. So u equals 5 root x minus 3. And the du is the integral of this, or derivative of this. So 5 over 2 root x dx. So observe that the entire top is u. What you're missing is 5/2. So you will put 5/2 and 2/5 in front. Actually, I used to do that red. So I need 5/2 and 2/5 in front. So now, all of this in this peanut, all of that stuff is du. So if you look at this integral, it's 2/5 integral u du. We converted something that was looking crazy into a simple integral that's just going to use plus 1. It's 5 over 2. So that's that one. Root x in denominator and dx. All together create du. And the other 2 over 5 we copy. So all of this is 1/5, 5 root x minus 3 plus c. And you will be using this a lot.
What happened to the square?
It's right there. Look. Nice. Thank you. All right. Here's one for you. Let's see what you get. These are the introductory problems. So, yep. We're not expecting anything too crazy now. What's u? What's du? 3dx. I don't have 3dx. If I put a 3, I put 1/3. I can put 3 also here. Doesn't matter where you put 3. So once you put the put that, it becomes 1/3 e to the u du, which is 1/3 e to the u plus c, which is 1/3 e 3x minus 1 plus c. All right. Now, the next part, when you start talking about more complicated problems, you're supposed to look for something that I like to call function derivative pair. So, look for function derivative pair. This will be much more important later in Calc 2 because you're going to have more integration techniques, and then you will have to figure out which one is the right one to use. When you have a derivative now, you are figuring out whether it's a chain rule or a product rule or a quotient rule, by implicit differentiation. You are choosing the appropriate method. Well, for integration, so far you only know basic integrals or U sub. So not a big deal to learn something like this for the next test. But in Calc 2, you are going to have additional 5 or 6 integration techniques. And this is the most frequent and the most basic one. So if you spot the function derivative pair, that means that the problem could possibly be solved by U sub. If you go back, you always see there is a function and its derivative is a constant which you can fix. Here is the square root function whose derivative is 1 over 2 root, which you also have. So every time you had a function and the function ended up being u and the derivative gave you du. So now you have integral of x to the 5 minus 3x to the 9th power times 5x to the 4 minus 3 dx. Hopefully you see that this part is the function and this is the derivative of it. If you're able to pick that quickly, you immediately know that u is x to the 5 minus 3x, and the du is what? 5x to the 4 minus 3 dx. Now in parentheses, obviously, because dx multiplies both. So that means that the whole thing here is du, and this part is u to the 9. So we quickly fix this problem as u to the 9 du, which is 1 over 10 u to the 10 plus c, which is 1 over 10 x to the 5 minus 3x to the 10 plus c. Done. du is all of this, right? Because you look at your derivative to find what the dx is. What happened?
The equation under that, when it's the u9 du, and then it's equal to 1 over 10 u to the 10 plus c.
Oh, well, this is the notation for the integration. Once you integrate, you don't put du anymore because remember that it computes the area and that was the width, so this is actually the answer.
Okay.
So that's why the times du doesn't exist anymore.
Okay.
Fair? So now we have, let's go with sine to the 8 x cosine x dx. See what you can do with this.
That's okay. I just did it.
Thanks. I gotta go closer because
You gotta get that good shot.
I know him.
Yeah,
I know. I got it. Next. Let's see. You good? It's rain. Alright.
Okay.
I keep it on a quick draw.
So DU would both be cosine x and dx, right? Because you can write it as u to the 8th, and the derivative of u to u is cosine.
Perfect. Yep.
But that du encompasses both cosine x and dx, correct? Like
Yes.
okay. See that spray impression.
I know. Coming around again.
That's turmeric, Professor. It's turmeric.
Alright, linear linearized is really not that bad.
Oh, you want to do it?
Hell no.
We do what? Yeah, go up there and show the work out.
Oh, you know?
Go up there and show us.
All right.
And then you just plug in.
I don't want to show off.
So u is equal to what?
Sine x.
And du is?
Cosine x dx.
Nice. So all of this is du. And we have u to the 8th.
Don't care about u, I care about dx.
Yes, that's the sentence for the, to remember to do the conversion back.
How do you do this?
Like this. So sine to the 8x, right? Sine to the 8x. So if sine is equal to u, then the derivative of sine is cosine, right? Dx goes to the other side. So the entire cosine x dx is du. And then sine x is u, so u to the 8th. Integral of u to the 8th is u to the 9 over 9. So we are transforming this complicated trig thing into a much simpler integral to solve. And then we bring back the trig functions once we integrate everything in terms of u. Now, these kind of problems will be taken to the next level in Calc 2 with the trigonometric integrals. So let's see what else is cool. How about secant squared x tangent cube x dx? So do we have a function derivative pair? What is the function? What is the derivative? U equals what? So what's u equal to? Secant? So what's du?
Wait, it's tangent. Yeah. It's tangent because secant squared x is the derivative of tangent.
Nice. So it's tangent because its derivative is secant squared x dx. So this is where the skill is for this section. Figure out which one is the function and which one is the derivative. If you pick secant, then the derivative is secant tangent, and you're just going to get stuck with extra tangents. So let's, you know what, let's make a wrong sub first. Let's say u equals secant x, and du must be secant x tangent x dx. You see that you actually have 3 tangents, but your substitution has only 1 tangent. So actually the problem can be solved that way also, but it's much more work. Wow. It was just luck. Because this secant now, you have to break into secant times secant. 1 secant goes for u, 1 secant goes for du, and then you have 2 tangent squares left. You transform those into secant squared minus 1 using the Pythagorean identity. So it will be a lot of work to solve it this way. Not every integral can be solved, but yeah. Much faster way is to just say u cubed du, right? Because secant squared and dx together are going to be du. And we have 1/4 u to the 4 plus c, which is 1/4 tangent to the 4th x plus c. Ryan, come over here. I don't want to get up. You can just go up to here, to the corner of this desk. Oh, just go here.
Is this close enough?
There you go. Oh. All right. All right, so we're not going to do any crazy stuff today because we're going to go with the review. I want to give you maybe 2 more examples from the easy part. We'll do tomorrow, we'll do the limits, and we'll do the substituting when it's definite integral that has numbers, right, lower upper limit. And we also do the back substitution tomorrow. Today we're just going to do these basic ones. So here, let's see. How about, oh, this is a really good one. 1 over 10x minus 3 dx. This is extremely frequent integral in Calc 2, like type of the integral in Calc 2. So let's see if we haven't done one like this so far.
Yes, move over there. You want to sit over there? Yes, please. And we'll move the prime like this. And we're going to start. Some fries. Oh.
Someone's missing the button of the pen. Underneath, it's a little train that would carry the car underneath the what is that? Oh no, that's a different thing. That's the extremely high-speed train that connects for passengers. Maybe they want to put a car, but that has nothing to do with you know, like we play air hockey on the I'm not sure exactly what the numbers are, but you have 40 minutes flight. Not matter of, you go coast to coast to the airport. Yeah, airport takes 6 hours.
Magnets to make it go. Like principle of the coil spinning thing at the railgun that caused the train to heat up a lot. Because like most railguns after a point fire like slag because of how much it heats up because of the electromagnetic propulsion.
But yeah, this is the same coil shooting constantly. Over here, it's gonna shoot once and maybe another 10 hours. One is later because the coils are right here. This is a two coil. This is a coil. This is a coil. When you're shooting the railgun.
I know. Because I want to see where it's going. No, I want to see where it's going through. But I also want to know why.
All right, so what did you get as the answer? Brian, what do you got?
Oh, Stephanie's done.
What?
Huh?
What'd you get?
So U would be 10x minus 3. And du dx would be just 10 minus. Oh, yeah, it does. It's 10. No, 10 dx, yeah. So you need to change that, which is multiply that by 10, that by 1 over 10. So then the function becomes 1 over 10 u to the 10. No. Just like the, yeah.
And what is this?
Yeah. 1 over 10 u, which is 10 over x to the third, and then d, which is 10.
So what is the integral of du over u?
Oh, it's just u over u squared divided by 2, right? No, no.
This is u to the minus 1 du. If you do plus 1, it's going to be 0. So that's not good. 0 in denominator. That's not good. So what do we do?
Oh, yeah.
Oops. Plus c, not. This is extremely, extremely frequent as you are working on these. Technically every single one. And as you can see, we're not even doing the u sub in Calc 2 because it's known what they're going to equal to. You learn different things in Calc 2, and then the ending would be exactly this integral. So let me just find it right here. You see? You can do u sub on each one of these, or you just know that they all work out to be ln's, which is the thing that you're learning now. So that's why I said, you know, you're not supposed to forget these things, because then later you have to relearn them. Let's see, what else is cool. This one, we never had anything like this. X to the 9 sine x to the 10 dx. Let's see what you get there.
This is spicy. Not spicy enough. It's like that little bit is best. It's like that.
What are you supposed to look for?
The derivative and the function and its derivative.
Okay, so what are the function and the derivative?
I want to say that the function is x to the 10.
Why?
Because the derivative of x to the 10 is 10x to the 9, so I feel like we could change that.
Good.
Yeah.
All right, you got it. Let's see if you can finish it up. You got 15 seconds, no pressure.
And the movie's so cool.
All right, so we need a 10 and 1 over 10 in front. So 1 over 10 integral sine u du, because this together with dx, use your eyes, they look the same, right? 10 x to the 9 dx, all of that together is du, and then you have sine of x to the 10 is u. The integral of sine u is negative cosine u, so negative 1 over 10 cosine, and instead of u we have x to the 10 plus c. So we're going to come back tomorrow for part 2 after the exam. I'm going to restart the stream and we are going to do the review after the break.